Hey everybody, it's Art. I found a really cool cross-site scripting challenge on the web last week, and somebody posted the solution to it, and I thought it would make a great video for us to walk step by step, solve the challenge, learn a little bit about cross-site scripting, and let's just dive right in. All right, so last week I found on Twitter a cross-site scripting challenge. It was hosted from this company called BugPOC, and they seem to have a really cool platform, by the way, for tracking and recording your proof of concepts for bug bounties. So I definitely encourage you to check them out. BugPOC. You can see the Twitter handle for them here on the screen. And I spent about maybe 2 hours trying to play around with the cross-site scripting challenge. I got maybe halfway into it myself before I had to stop and get some real work done. But I did see a couple of days later this post on Medium, which has the solution to the challenge. So Gautam, whoever you are, thank you for posting the solution to this. It certainly strikes me that there could definitely be multiple solutions to how this challenge was solved, but I would highly encourage you to look up Gautam's solution to the BugPOC cross-site scripting challenge. But I'm going to take you step by step through how I attacked the application, and then we'll pivot into Gautam's solution. And I think this will be a really cool exercise in teaching everybody how to do cross-site scripting attacks. So let's dive right in. The challenge itself is hosted at calc.buggywebsite.com, and I'll be sure to put this in the link on my YouTube video so you can check it out yourself. And what you can see, it's just a hosted calculator. So 7 times 7 equals 49. So you might be asking yourself, well, how exactly would you cross-site script something like this? I mean, suppose arguably you might be asking yourself, why would anybody bother trying to cross-site script a site like this? But those really aren't important questions. I think let's just dive right into the tech and really stretch our legs, flex some muscles in the HTML and JavaScript areas. As a penetration tester, the first thing I'm really going to do is to go down to View Page Source by right-clicking on the browser, and brings you right to the HTML, and thankfully none of it's minified, so it's really, really easy for us to read. Taking a look through what's in here, we've got a bunch of meta properties. None of this is really super interesting. Some Twitter things, a couple of fonts that they're loading. They are loading some styles. There is a content security policy embedded here in the raw HTML. This is going to become important later. I'm not going to dive right into this right this second. Just be aware that it's there, that whenever you see a content security policy, you're really going to want to inspect it carefully, because that's going to lead you down the path of how to actually attack this application. A couple of other things are going to catch my eye as we scroll through the raw HTML here. Well, one, I see an iframe, so we're going to go check that out here in a second. We see ng repeat, which tells me that they're using AngularJS. We'll take a look at that a bit here in a minute. Specifically, they're using some of the AngularJS templating, so that may be an interesting thing for us to check out later. Again, here at the bottom, we see that they're loading Angular, they're loading jQuery, and again, we have some other scripts that are being loaded as well. Before I go any further, I want to highlight another thing that I typically do as a web application penetration tester, and that's to make use of two of my many Chrome extensions. Number one is this thing called Wapalizer, which right off the bat doesn't actually tell me as much as it usually would. So sometimes Wapalizer is smart enough to identify any JavaScript frameworks that might be on the page, but it's not catching the fact that AngularJS is here. It does tell me that we're being hosted on Amazon S3 using AWS, so just good things just to keep in mind, although for this particular challenge, it's not really anything useful. Other plugin I really like to use is Retire.js, and this is where you really start to get some insight about how to attack an application. So we can tell we're using AngularJS version 1.5.6, jQuery version 3, and we have links to all sorts of CVEs, known vulnerabilities that have been reported against these particular versions of AngularJS and jQuery. Now, I'm not going to pivot to read any of these here, but if you were to go and do some research on this particular version of AngularJS, you would find that it is susceptible to cross-site scripting attacks, specifically by allowing you to eval raw input within its HTML templating functions. So those were some of the things we saw here between our mustache braces. So again, without knowing anything else about this application, I'm immediately going to start honing in on the fact that if I'm going to create a cross-site scripting attack, it's probably going to be involving my AngularJS templates. So without further ado, let's dive a little bit further into the JavaScript that's loaded on the page. I'm going to start by looking at script.js down here at the bottom. And when we come to look at this, we're going to find some of the raw AngularJS code that, if you're familiar with AngularJS, none of this will be all that complicated. If you're not familiar with AngularJS, again, probably not that difficult to figure out. I mean, there's a couple of funny variables like $scope that you might not really know what to do with. Those are going to be properties on an object that's managing a piece of the DOM, the document object model in the browser. So we don't really have to dig into too much of this, but really we're going to just scroll through here and see if anything catches our attention. So we see we got a function called command, we got a function called add decimal, update current num. This thing down here at the bottom, send equation. So this is not part of our AngularJS scope, but what it is doing is making use of a native JavaScript API that's in the browser, which is posting a message to the iframe that was configured here in our source code. So iframe with the name of the iframe. You can see that's being posted. It's posting a message to that. And so I guess at this point, again, as an attacker, I'm trying to really hone in on where I'm going to be able to execute an attack. Post message is one of these really interesting things because in order to create a cross-site scripting attack, I have to be able to get my payload into the application running in the browser. There are a couple of ways that I might try to do this. Number one might be to look for any query strings in the URL. So as I do things like 9 plus 9, hit equals, I don't see any query strings being added to the URL up here. So that's probably not going to be my attack vector. Another thing I might do would be to look at things like my local storage. And I don't see anything stored in local storage. I don't see anything stored in session storage. There's no IndexedDB. There's no web SQL. Are there any cookies? There's no cookies. So as an attacker, I'm noticing that there really aren't that many attack vectors for me to inject a payload into this application. If If I can't take over the cookie, if I can't take over local storage, if I can't provide a query parameter with a payload, the only other thing I can think of, looking at the application code here, is the ability to post a message into the application and have it respond, hopefully, by adding that payload somewhere in the DOM. So, for the sake of argument here, let's take a look at send equation. And we can see it's being used in a couple of places. So when you call the contact operator method, it's going to call send equation with our the equation that's being stored here in our AngularJS object. The command function is going to send equation with an on or off. There's no real way to dynamically update that, so it's probably not there unless it falls all the way down here. We're going to sending the equation with the equation from our scope. If I add a decimal, it's doing the same thing. If I update the current number, it's doing the same thing. So again, just a pure guess at this point, and we haven't looked at all that much code. I would guess if we could somehow pollute the equation, it's going to be able to post that message into the iframe where maybe we're able to do something with that. So let's X out of that, come back to the iframe. Let's take a look at the HTML for the iframe. And we had to view the source code because, as we can see, there's really nothing being displayed here in the frame. The source code is going to tell us there's really not a whole lot going on here. We do have a little bit of styling that's happening, but the more interesting thing for us is the fact that we're loading another JavaScript file, frame.js. And looking here, we're going to see it's going to receive a message. So window add event listener, whenever it receives a message, so that's going to be coming from that, that post message down here. Whenever we post a message, that message gets received as an event listener using the receive message function. This is where the rubber meets the road. We can see we're doing an initial bit of validation. Say if the sender of this message does not have as its origin something that matches this regular expression, which is going to be http://calc.buggywebsite.com, then just return. Don't do anything. This looks to be pretty strong validation, so let's keep going here. When we look at what the message, so this is event.data, will be stored in this message variable. The message could be the string off, in which case it's going to change the background color of the document body here in the iframe. If the message is the string on, again, it's going to change the color of the document body. And otherwise, if it's not on or off, so message could be literally anything else at this point. It's going to inject that into the inner HTML of this particular HTML document, which inner HTML is one of these big, gigantic red flags to any web application pen tester, where if you can find inner HTML being set directly, it's usually a good indication of being able to execute a cross-site scripting attack. So this is really the thing that we're going to try to take advantage of. Caveat is that in order to get to this line, we have to pass two additional bits of validation. There is the message cannot include a single quote, and the message cannot include an ampersand. So this is going to limit us just a little bit in how we create the payload. But for the moment, let's see if we can't at least get a proof of concept working, that we can execute some sort of injection attack to this application. All right, so the first thing that I want to do is to create a proof of concept that's going to allow us to post a message into our iframe so that we can execute the attack by attacking the inner HTML function. So in order to do that, we're going to create an HTML file that, number one, loads into an iframe that inner frame of the buggy website. So that frame HTML, we want that to be here as well, so that we can try to post a message directly into it and see if we can't take advantage of it. So we've got that loading here. And then we're going to create a text area for us to input some arbitrary text that we're going to then, when you click a button, it's going to call post. This post method is going to grab the inner content of our text area. So ID XSS is what we're getting. So we're getting that value, and we're going to post a message into that iframe using the post message API. So popping over to our browser, we can see this is what this proof of concept looks like. Now, there's one important thing that I've done locally per Gautam's instruction in his write-up on Medium, and that was, in order to execute the attack, remember in the frames the frames JavaScript file, it has a check for if you're running on calc.buggywebsite.com. That seems like it's going to be a hard thing, or that seems like it's going to be a hard piece of validation to get around until you look very closely at this regular expression, where you see we're escaping things like our slashes, but we're not escaping the dots inside of the sub and top level domains. In regular expression, the period, the dot character, is referencing a literal any character, which means that if we could create a domain that replaced those dots with literally any other letter, we'd be able to bypass the validation of this particular script. So what we've done locally on our machine is to create a calcx buggy website xcom.local, and I've got this running locally on port 5000. So the way that I've been able to accomplish this is by editing my etc hosts file, which I've hidden most of for the sake of security here on my local computer. But you can see I have a line that says the IP address of 127.0.0.1, which is my local machine, calcx buggy website xcom.local. This address will be accessible to me whenever I'm running a local host process. It'll resolve back to my local host. So now when I fire up my local host using a command line utility that I have installed, I'm able to replace the 127.0.0.1 or localhost with calcx buggy website x.com or .local, making sure I find the right port that my local host is running, and it will automatically resolve this for me, so I can actually run this particular proof of concept. And what we can see is that if I type in, let's say 55, and I hit XSS, so here's the iframe. It is using the post message API taking whatever I've typed in here and throwing that inside of the iframe, which is pretty cool. Now that we're able to inject raw content directly into the iframe, we need to figure out a way to inject some sort of malicious payload that would be more than just vanilla numbers or generic text. And what we have to do at this point is start inspecting the content security policy of this iframe. So I've pulled up frame.html and I'm inspecting its source code. And again, we see here a meta tag for the content security policy, which tells us a couple of things. One, the script source is set to self, so we can't load any external JavaScript files. It does have unsafe eval enabled, so that's one bit of good news for us. We should be able to inject some raw evaled code directly within the page, even though we can't load JavaScript from an external host. Object source is set to none, so that's not going to do us any good there either. So I feel like we've got a pretty good attack vector in being able to run eval on this frame. And if you will remember, AngularJS is susceptible in this particular version to templating attacks. So being able to run eval within that AngularJS template is looking more and more like the option where we want to go. So coming back to our proof of concept page, again, we can pretty easily put some raw numbers in here, but we can't do things like putting script to alert and if I could type, can't do things like put a script to alert here. It doesn't actually do anything inside of the iframe. So the question becomes, what can we inject into that iframe such that we're able to execute some sort of eval attack? And one idea that was floated in Gautam's Medium article was to use an iframe with a property of source stock. And so what this allows us to do is to create yet another nested iframe, inside of which we can depict exactly the HTML code we would like to execute. In Gautam's example was to use a script that loads AngularJS and sets up the Angular application. So a div that has this ng app attribute on it allows us to then use AngularJS templating inside of it. And what you can see here is that we are executing a JavaScript expression 7 times 7, which should equal 49. If this attack here is viable, we'll be able to see the number 49 and nothing else displayed down here in the iframe. And so you can see another iframe is created and the number 49 is there. So that is correctly telling us we're able to run JavaScript expressions inside of the Angular template. So the final piece of this, now that we've been able to demonstrate that we can post a message to the frame and we've successfully bypassed the content security policy by running JavaScript directly within a payload sent to the frame. The last bit is actually being able to execute an alert that shows the domain of the application running. If we go back to Gautam's article, what we'll see here is the challenge is to successfully alert the domain, bypassing the content security policy, works in Chrome. So what we need to do is be able to execute an alert statement inside of this POC. So the first thing you might try to do would just be to run a simple alert directly within the ng app, and we'll see that doesn't actually work. So we need to get some creative cross-site scripting working now that we know exactly the attack vector that we need to attack. So one of the examples that Gautam shows us in his Medium post is using the $eval function from AngularJS, which should be able to do things like to evaluate a JavaScript expression into an executable string for us to run inside of this AngularJS template. And one of the approaches that he took was to do something like take a raw object and toString it, and then take that and find the constructor, which you can see does successfully create an object for us. The purpose of doing this is to then cascade this attack into reading into the string a series of character codes, because the AngularJS template does appear to be smart enough to filter out some of the expected alert or window commands. So if we could find a way to then create this string and then do a from character code, execute some sort of command from this, that would really be the way to go. And Gautam's article goes a long way to discussing what to do inside of this payload. And his example is to call this a equals toString constructor.prototype, sets the character at a trimmed version of the a variable, and then to eval some sort of alert here. And well, if we took this and tried to execute it, what Gautam noticed is that number one, he's got single quotes here in the payload, so that's not going to be executed. I did try to use backticks, thinking that maybe a string template would get past the filter, and it didn't. Admittedly, I'm not entirely comfortable with the way that this is written, but what Gautam gets to, if you read through the rest of his article, is to say, well, if we can somehow convert this bit of code right here into ASCII, and he uses a Python script in order to do that, so you get this this fun payload. We should be able to copy this payload and come back to our proof of concept and inject that directly into our payload and run this again. And I may have missed a character when copy and pasting this. Let's try to grab the whole thing here, because he gives us that final payload, and we can drop that in and execute it, and all of a sudden we do get calc.buggywebsite.com is the domain of the iframe for where it's running, so it does successfully execute that cross-site scripting attack. So this is a great exercise in attacking a vulnerable version of AngularJS. I hope Gautam was the one who got the $500 top prize for making his submission to this BugPOC cross-site scripting challenge. Seems like he spent considerably more time on this than I did. As I mentioned, personally, I wasn't able to get much past the posting the message to the iframe. But kudos to Gautam for walking us through how to solve this challenge. thanks again to BugPOC for putting out this really fun cross-site scripting challenge. I had a lot of fun trying to solve this. Gautam, thank you very much for putting your write-up up on Medium, because I don't know if I would have been able to solve this without your help there. And certainly, if any of you watching this have any comments, please put them down in the comments here below. I'd love to hear your discussion on the attack payload used for the AngularJS template injection. If you have any other solutions or saw any other write-ups, I'd really love to see those, because I feel like going through the motions of following someone's write-up really is the best way to learn how to do effective cross-site scripting attacks. So this was a lot of fun. I definitely learned something, and I hope you did too. If you find any other challenges out there online, please send them my way. I'd love to, certainly try to crack them myself. Maybe we can create some more videos so we can all keep learning how to do cross-site scripting attacks. So thank you very much for watching, and I'll catch you on the next episode of Hacking JavaScript. Thanks again.